Good morning, pre-calculus. Today is another day, and today we're going to look at section 9-5 and looking at the binomial theorem and see how that is used when we want to expand a binomial. And with that, and without further ado, Mudrock, go and hit those lights. All right, like I said, we are going to expand binomials. Again, you have done problems in the past where like we take the quantity x plus 2 and you square it. That's like taking the problem going x plus 2 times x plus 2, doing your FOIL method, and you'll get x squared plus 4x plus 4. Again, that is something rather simple to do. But what do you do if you run across a situation where you have the quantity x plus 2 raised to the fifth power? Well, the multiplication of that can take a little bit of time, but the application of the binomial theorem and specifically the binomial expansion is really going to help you out immensely. So again, on page 3 of your HD&Cs, again, if you can write down in there your binomial expansion. So if you need to pause your video, you may do that. And the new thing we're going to deal in here is find these coefficients of your binomial expansion. And we have to use what is called combinations. And down below is the step-by-step procedure if you want to find they call it NCR on your calculator. On the left-hand side, that is for calculators like the TI-83. And the right-hand side is dealing with calculators like the TI-84 plus C above. Okay, I'm going to show you how to use all these. Okay, it's really not that hard. I'm trying to just cover the basics for this section, and probably the basic in here is binomial expansion. So the way to do this is just do examples. So let's look at our first one. We want to find the expansion of the following. So in other words, in this case, we have the expansion. We want to expand x plus 2 raised to the fourth power. Now again, that is like saying x plus 2 times x plus 2 times x plus 2 times x plus 2. And if you do all your multiplication, this is your answer. This is the expansion of this. But how did they get this without doing the multiplication? Going back to the binomial expansion, we have to identify within our expansion what is the value of A and what is the value of B. Once again, A is the first term of your binomial and B is the second term of your binomial, and your n represents the power raising it. Now we're going to fill in the details here. I'll show you how to do that. So the first things first is I set the problem up like this. And all we got to do is find out what these coefficients are. And I'm going to show you by using your calculator, okay? So once again, it's really simple. Turn your calculator on. You'll want to go to Math. Move your cursor over to Probability. Find NCR minus 3. Again, to do this, we've got to ask ourselves, what is n? N in this case is 4. And in order for us to find 1, 2, 3, 4, 5 coefficients, we have to go and set this problem up so we can find all 5 of them. And to do that is we have to use a character, different parentheses. So second, this parentheses, starting off with 0, we go all the way up to 5, because we have 5. We go all the way up to 4. I'm not all the way up to 4. Sorry, all the way up to n, because that'll give us our 5 terms. I'm messing up here a little bit, and close it off with parentheses. And then this will represent your 5 coefficients. Hit enter. And those 5 coefficients are 1, 4, 6, 4, and 1. Now, I happen to skip part of this section. If you want to do the Pascal's triangle, you could have found these by looking at the Pascal's triangle in your homework. So how did they go take this up to here? It's really simple, okay? It's all order of operations. I know that 2 to the 0 is 1. 1 times 1 is 1. Up here, using the binomial expansion, we go n minus 0. That gives us x to the 4th. Excuse me. Next, 2 to the 1 power is 2. Times 4 gives us 8. And then 4 minus 1 is 3. 2 squared is 4. 4 times the coefficient is 24. X squared. 2 cubed is 8. Times 4 is 32. Again, you should see a pattern here, okay? At the same time, you should notice that each of your terms, your power of x, is in descending order. 4, 3, 2, 1, 0. And then we have another a variable over here. It'll be increasing order. All right, so that is number 1. All right, number 2. Here we have 2x plus 3 to the 5th power. That means 2x plus 3 multiplied by itself 5 times. Here is our expansion. How did we get that? Once again, using your binomial expansion. Once again, we set it up. Again, the a here represents the first term of your binomial, n represents the power. The second term is b, 0 power, and you're going to notice that your first term goes in descending order. Your second term goes in ascending order all the way to starting at 5 or going to 5. Okay, then we have to find the coefficients. So, once again, to find this coefficient, we have to go back and do math, probability, NCR. Again, we're going to be starting off with our first term, which is 5. Second bracket, and then we start off with 0. 1, 2, 3, 4, 5, 6. So we go 0 to 5. Close it off with the parentheses, hit enter, and we get, in this case, 1, 5, 10, 10, 5, and 1. All right, now going back to your expansion once again, we know that this is our first term with the power of 5. That's your A, if you think about it. This is your B. Your A goes in descending order, so 5, 4, 3, 2, 1, 0. You'll probably see that up here. Then your B goes in ascending order all the way up to 5. And after this, it's all math. 3 to the 0 power is 1. 1 times 1 is 1. And then we have to figure out what 2 to the 5th is. 2 to the 5th is 2 raised to the 5th, which gives us 32. Again, it's all order of operations. 3 to the 1 power times 5 is 15, times 2 raised to the 4th power gives you 240. 3 squared is 9. 9 times 10 is 90, times 2 raised to the 3rd power, and that's where they get 720. All right, you should see a pattern here, okay? You should see a pattern here. All right, now number 3, is 3x minus y to the fourth. Again, I'm not going to work this one out because by now you should be able to find out your coefficients are and be able to do your order of operations, and you'll be able to see what this is. Okay, so again, I'll let you guys work that one out. Again, based upon my notes, I did this earlier. So again, let's just go back and redo this one. So math, probability, NCR, again, 4, bracket, starting off at 0, all the way up to 4. Close it off with bracket, and you get 1, 4, 6, 4, 1. And then order of operations, order of operations, order of operations, and you'll figure out this is answer to your problem. So once again, using the binomial theorem and the binomial expansion, you'll have no problem figuring out the expansion of a binomial raised to some power. All right, guys. Thank you so much for listening. We'll catch you later. Bye.